Depends on your audience.
All right, we can get started here. Thanks you guys for coming. We've got a couple of Google folks here to give us a talk today. Alex Komoroske and Rob Dodson. Rod's a developer advocate for the Chrome team, and Alex is product manager for Polymer and the Link engine. And they're here today to tell us about Polymer.
Awesome. Cool. Well, thank you guys for being here today. It's awesome to be here at Yahoo. My name is Rob Dodson. I'm a developer advocate on the Google Chrome team. As Matt was saying, specifically, I work on a project called Polymer. This is all my contact info. If afterwards you guys have questions about Polymer and you want to reach out, please feel free to hit me up on any of these social networks. We're going to cover a bunch of stuff today. We're going to try and cram in as much as we can. We're going to start off by talking about what is Polymer, what are web components. Maybe you've heard of some of these terms on Twitter. You've heard people mentioning Shadow DOM, what the heck is all this stuff? We're going to look at some ways that you can actually start working with Polymer today in your projects and your prototypes and things like that. And we're going to save some time at the end. We're going to do a little bit of a code jam so you can actually see some of the things that you're able to build using Polymer. But to start us off, I want you to kind of close your eyes for a bit, and I want you to go on a little journey with me. I want you to think back to when you were first starting out doing web design. I want you to remember when you were just a wee little web developer. And I want you to think about the first website that you ever built. Okay? And chances are it probably looked something sort of like this. Not the most exciting thing ever, but this is a fully functioning web app. You can buy a t-shirt with it. And it might seem old hat just to think about working with HTML elements like this, but it's sites like this that really gave us the foundation for the web as we know it today. Here we're just sort of bolting together a few elements. So we've got some inputs and table element, select element, and we're cobbling them together and we're building something that's kind of interesting, kind of rich, and for a beginner, this is sort of like a great place to start. And I want us to stop for a second. I want us to think about everything that elements give us, like elements, HTML elements, and what they give us as sort of the building blocks of the web that we know. I know that today we have these big JavaScript libraries. We have these really fancy libraries that we use to build our applications, but underneath it all, it's still HTML. That's still sort of the underpinning for everything that we do. And there's a lot of really wonderful aspects to elements that perhaps we've lost sight of as we've been going through this big JavaScript renaissance. And I want us to spend a little bit of time thinking about what some of those cool aspects are and how they help us do our job every day. The first thing is that elements are encapsulated. So encapsulation is something that's really hard to come by on the web these days, but elements are, by their very nature, just sort of encapsulated by default. So here we've got a select element, and select is pretty interesting because it has its own behavior and it has its own styling kind of built into it. And we don't have to write any CSS or any JavaScript to make that happen. It just kind of comes for free when we use the element on our page. It's also really easy to understand how to work with select. You can just look at this very simple markup and kind of grok what's happening very quickly with that sort of one-to-one relationship. Elements are also configurable. So again, working with select, if we just add a disabled attribute to a few of its children, then it's very easy to change the behavior of the select element. And we've now changed also the appearance. So all of its option children are now grayed out. With a selected attribute, we're able to default to this extra large element, right? So we don't have to write any JavaScript to make this happen. We don't have to write any cool CSS to make this happen. We just configure the element and we get some new behavior. Likewise, if you add a multiple attribute to the select element, right, you've now totally changed its appearance and the way that it works. It becomes a multi-select box, and you can just hold down Command and click a few of the elements inside of it, right? Totally different element, and it was just one simple change here in the markup to get us this new state. Elements are composable, so if you take an opt group and you put it inside of a select element, the select element is smart enough to know that when it has different children inside of it, it should react differently. It should give the user something different. So now instead of our select box, we're going to get these little subheaders for our different opt groups, and it knows to kind of nest the option children inside there. It's It's just composing these simple elements to give us something a little bit richer and a little bit more interesting. And if you take select and you place it inside of a form element, now you've built something way more complex. Now every time this form gets submitted, it's going to grab the value out of our select and pass it on to the server. So we didn't have to write any JavaScript to make this happen. We're just sort of bolting these things together like Legos, and we're able to scaffold something a little bit more interesting out of these sort of simple parts. Lastly, elements are programmable. So I've been showing a lot of the nice declarative API of working with an HTML element. But there's a whole other programmable side. We have things like selected index, which maybe doesn't make so much sense in HTML, but in JavaScript, this totally makes sense. You want to have these properties and these methods and these events that you can work with when you want to get into kind of using the behavior and tweaking the behavior of your element. So when you're working with an element, you get kind of the best of both worlds. There's a nice declarative side, and there's also a nice, rich, imperative programmable side if you need it. So what happened? This seems like a really nice way to work when you think about it, but we don't build our websites today just bolting together elements. Now we use big JavaScript frameworks, we use big CSS libraries. We've kind of left this world behind. And we all know the answer to this question. The reason we don't work this way anymore is because HTML just hasn't been expressive enough for us. It doesn't give us all of the tools that we need in order to make the sort of complex UIs that we want to build today. And so we've been forced to work around what the browser is not providing for us. So let's look at where we're at now. So building a tabs component is kind of like a quintessential component for the modern web. It's a seemingly simple component, which can actually be a little bit of a pain in the butt when you think about it. This is the sort of markup that you usually use when you're building a tabs widget. So you've got a lot of HTML here that's just trying its best to be semantic and scaffold out an element for you. And then you're going to come in later with a little bit of CSS to kind of hide some things, make it look nicer. And maybe at the end you'll use some JavaScript to kick off all the behavior. This is really typical of something like Bootstrap or Foundation, where you just go and copy a whole bunch of code out of some documentation and paste it into your app. But as we've been going through this JavaScript renaissance, now we're starting to move more of this effort into the JavaScript itself. So this is from Kendo UI. It's less markup, but now more JavaScript, right? We've increased the complexity in our script. And this trend kind of continues. YUI, Angular, EXT, right? So we have all of these libraries now that are pushing JavaScript to do all these things that maybe it wasn't originally intended to do. And I feel like this is unfortunate for a few reasons, but I feel like one of the main ones is that it sort of raises the barrier of entry for working on the web, right? If all of your UI is in this complex JavaScript framework, it's harder for new developers to get in. It's harder for designers to work with you. And fundamentally, all we want is something that looks kind of like this, right? Like if I had this to build tabs with, I would just use it the same way that I just use select. And I would drop this on my page, and I would style it, and I would move on. For, I guess, the past 2 decades or more, it's not been possible to do anything like this. You can't just make up your own tags in the browser. But thanks to a new set of technologies called web components, this is actually starting to become a reality today. So web components, if you've never heard of them before, are a set of emerging standards that allow developers to extend what the HTML language is currently able to do. And I want to give you just a high-level explanation of what they are. I'm not going to go super deep on these, but I do think it's important for you to understand conceptually how they work. So you've got templates, custom elements, shadow DOM, and HTML imports. Collectively, these all fall under the umbrella of the term web components. There's no one web component technology. It's these 4 things kind of combined together. Templates allow you to create your own reusable bits of DOM that you can stamp out over and over again on the page. If you've used something like handlebars or mustache before, it's basically the same thing, except now it's its own tag native to the browser. Custom elements allow you to create custom HTML elements. That X-tabs example that I was showing before is an example of a custom HTML element. Shadow DOM, which maybe some of you have heard of before. Shadow DOM allows you to create little encapsulated bundles of markup and CSS. So you can take some HTML, take some CSS, you can put it in the shadow DOM, and then you're guaranteed that that component that you've just created is going to render exactly as you intend it to. It doesn't matter if the parent document has more specific CSS or anything like that. The shadow DOM lets you scope your CSS to a little encapsulated component, which is really nice. And lastly, HTML imports, which let you load in custom elements. It lets you load in external HTML documents. So the same way that you can load in CSS and you can load in JavaScript, HTML imports just allows you to load in custom elements that you've defined so you can use them in your page. So that's web components kind of in a nutshell. But if you look at the current support picture, it's good, it's encouraging, right? Chrome is all about this stuff. Firefox is really gung-ho. Opera supports it because they're a fork of Blink. But just in general, it's still a little bit spotty, and we're still not quite ready to start using these things in production in their native format. But we want people to use these things. We want people to start messing around with these technologies so they can give us feedback, so we can make sure that the specs that we're writing are correct and the syntax is what everyone wants to use. So at Google, we've started a project called Polymer. And Polymer is a library that uses all of these new web component technologies to allow you to start creating your own custom HTML elements today in all modern browsers. So that's IE 10 and above, Safari 6 and above, mobile Safari, current Chrome, current Firefox, Chrome for Android, etc. And that probably sounds like a really big undertaking, like how the heck is that possible? So conceptually, it helps to think of this in terms of layers, and we're going to sort of illustrate how we get to this point. So this is sort of our layer cake of awesomeness. Down at the bottom, that little gray block down there, that is the current browser landscape. That is, whatever is natively possible right now. And the first thing we're going to do is we're going to add a layer of polyfills on top of what the browser is currently capable of. We call this layer of polyfills the platform. And it's the platform's job to add support for all of those web components technologies, so anybody can start building their own elements. Basically, it just jumps everyone into the future, so now they can actually start working with these cool new technologies. Then we go a step further and we add another layer, which we call Polymer. Polymer itself is an opinionated way to work with web components. It's basically a layer of sugar that sits on top of that polyfill layer to give you a lot of developer features, things like two-way data binding, change handlers, automatic node finding, and most importantly, a really nice, clean declarative syntax for creating your own elements. The last thing we do is we ship with a bundle of pre-built elements. So if you don't quite feel ready to get down to these lower levels, but you do want to play around with some new custom elements, Polymer ships with a set of elements for UI and non-visual work. So if you want to actually just start dropping those into your project and playing around with them, we've got that as well. So that means there's 3 ways to work with Polymer. The first and sort of the easiest is to just start using the elements that have already been provided for you, the elements that Polymer ships with, and the elements that are created out there in the open source community. The second is to create your own elements, and hopefully you all start doing this. So if you feel like you've got sort of a bit of reusable functionality in your code base, something that you think could be turned into an element, we want you to start figuring out if you can actually bundle that up into its own tag and start sharing it with your teammates and sharing it in different applications. Lastly, if you want to work with sort of that bottom tier, that platform layer, you can work directly with this new modern web platform. All of the polyfills that are contained in the platform are standalone, so you can actually break them off and just use them individually. If you don't feel ready for all of Polymer, but you do want to experiment with imports or templates or something like that, you can just take one of the polyfills or a couple of them and use them in a separate project. So I'm going to detail how we do each of those different modes of work, and we're going to start with using elements, since that's the easiest to get into. When you're thinking about working with elements, there's this mantra that we want to get into your heads. This notion that everything is an element, or everything should be an element. And the idea here is, if you're confronted with a problem and you feel yourself sort of like reaching for the JavaScript, you're like reaching for the jQuery or whatever to like solve your problem, I want you to stop and think, can I solve this with an element instead? Can I instead reach for an element and use that in my page instead of a whole bunch of script? And to make this easier on you, we ship with this set of pre-built elements. So these are our UI elements. And we have elements for accordions, overlays. We have this really nice card widget that we ship with. So if you've seen Google Now before, and you've got these sort of like cool swipeable cards, things like that. A sidebar, this is sort of your classic like expanding, collapsing sidebar. has sort of nice, neat animated effects, and it runs at 60 frames per second. And yes, we also have our own tabs element. So kind of piggybacking on the earlier example, this is Polymer UI tabs. To include it in your application, it's really easy. You just need a single script include for that platform layer. And then you use an HTML import to include the Polymer UI tabs HTML file. And after that, you're done. Like, this thing's ready to use. So using the Polymer UI tabs element is really easy. You just drop it into your HTML. You can configure it with a selected attribute to specify which of the tabs should be selected by default. And inside, you can just add spans or divs to scaffold out the tabs themselves. Really easy to work with. There's no additional stuff required. Another example is Polymer UI collapsible. This is something I see people doing with jQuery all the time, where they want to do the little jQuery like show and hide effect. But why do you have to write all that script for something so simple? It's really nice to put it just in your markup as a collapsible element and specify one element as the handler. This is going to be sort of your toggle handler. And then another containing element that's going to contain all of your content. So when we click on this click me element, it's just going to expand everything inside of that div, and click it again and collapse it, right? So you don't have to use jQuery to go query selector for some element, add a click handler to it, do the show hide toggle element, manage your state, make sure you don't screw that up. Instead, you can just drop this element on your page and you're good to go. So that's Polymer UI. That's just like a few of the UI elements that we have. And I think when you first start working with this stuff, your mind naturally gravitates towards UI. You're like, oh, cool, I can make my own elements. Well, then I'm going to make like a carousel and a drop down and a drop up. And we totally want you to do all those things. But then there's sort of this aha moment that occurs when you realize there's actually a lot of non-visual things that go on in the browser as well. And you can make elements for those. So we have elements for working with layout, for working with media queries, local storage, AJAX, the file system. And I know when you hear that, you might think, okay, that's really weird. I don't want to work with AJAX using an element. But when you start doing this, you actually realize it's really nice. It's a really nice way to work. So probably my favorite element to work with is Polymer Flex Layout. How many of you guys have worked with Flexbox before? Okay, how many of you like working with Flexbox? Well, you like the idea of Flexbox, but actually working with it is kind of really difficult. Yeah, so Flexbox has a ton of properties, and it also has a ton of vendor prefixes that you need to keep track of because it's gone through a lot of iterations. So when you're working with it, it's kind of a pain to like manage all of that in your CSS. So what Polymer Flex Layout does is it just takes all of that pain and it puts a nice declarative interface on top of it, right? So using the Polymer Flex Layout element, by default, everything that goes inside of it is going to be laid out horizontally. If you just add a vertical attribute, that's going to swap all of the children into columns mode. And then any child that has a flex attribute is going to flex to fill as much of the container as it can. If you take that away, it's going to collapse to be just the size of its content. So really easy to start using Flexbox just in your markup. You can save yourself from writing a lot of CSS or using a bunch of mix-ins or anything like that. And this element gets at something that I think is really important. Maybe it's kind of like a lower level idea here. And that's this notion of if you're not satisfied with what the browser is currently giving you, if Flexbox is just difficult to work with, you like it in theory, but it's kind of a pain to work with, you don't have to settle for what's currently there. With the ability to extend the language, you can actually solve these problems for yourself. You can take Flexbox and you can put a nice wrapper around it so it's a joy to use again. And that's something that I think is sort of fundamental to why these elements are so important. Okay, so that's using elements. There's a whole bunch of UI and non-UI elements that we've got today. We've also got a new set of UI elements that we're working on. So the elements that I showed are sort of in our labs repo at the moment, but we do have a bigger collection that's coming out soon, so stay tuned for that. That should be really exciting. But I want to move on now to creating elements. Once you start using elements, I think very quickly you're going to be like, okay, I get it, I'm sold, I like this, but how do I make my own stuff using Polymer? And Polymer adds a bunch of really nice features to make this easier on you. And the first of them, and probably the biggest, is declarative element registration. So if you look at the syntax involved to register an element natively using custom element syntax, it's kind of verbose. It's kind of wordy. You got to make sure that you set up your prototypes just right. You've got to extend just the right HTML element. And it can be a little fraught with peril. So rather than have to deal with all of that script, we just created an element that registers elements for you. So this is Polymer element. And using Polymer element, you can just configure it with a name attribute. That name is going to be the name for the new tag that you're registering in the browser. So here we're registering a new tag. We're going to call it my-element. And it's really important to note that any element that you create in the browser, or sorry, any custom element that you create using Polymer or web components in general needs to have a dash in the tag name. And it's basically to protect you from future versions of HTML creating an element that has the same tag name as your own. Like if you create a foo tag today and HTML7 also creates a foo tag, that's going to be a problem. So the dash is there to give you a little bit of namespacing protection and also to protect you from future versions of HTML. Now inside of your Polymer element, you just include a template. Inside of that template, any content that you put inside of there is going to be stamped out in the browser when your element is actually used on the page. So inside of this template, I've got a style tag that says that H2s inside of my element should be orange. And I've also got an H2 in here that just says hello from my element. So when I use my element on the page, what actually shows up is hello from my element in orange. Now, there's something really interesting to note here. This style tag is kind of loosey-goosey, right? Like that's like you definitely don't want a style tag like that just floating around on your page. But because we're using web component technologies and because we're using Shadow DOM, we're actually scoping that style to the element. So I've got another H2 up here. The slide title is actually an H2. But that style tag is not affecting the H2 in the parent document. It's only affecting the element that I've just registered, which is really great. If you write a lot of CSS and you're used to CSS being kind of like insane, this is a nice way to kind of wrangle it a bit. Okay, so some of you may have also noticed this NoScript attribute up here in the top right and wondered, like, what the heck is that thing? NoScript is basically a way to tell Polymer that I'm not going to include any JavaScript with this element. So I say NoScript, and that just says to Polymer, hey, you're good to just go ahead and register this thing. I'm not going to add any methods or properties or anything like that to it. If you do want to add JavaScript to your element, you're going to not use the NoScript attribute, and instead, down here in this script block, you're just going to call the Polymer constructor. You're going to pass in your element name. And then you're going to pass in an object as that last argument. And this object is going to define the prototype for your element. And so this is where you could add public properties, public methods, things like that. I've just added one public method called sayHello. So anytime someone selects my element, they can then run this sayHello method on that element. So I'm just going to alert howdy folks whenever someone calls sayHello. And I've got an example of my element down here, which just says I can say hello. And I've got a little bit of code on the page, which when I click on this element, is going to call its sayHello method to verify that it actually works. So really simple, straightforward way to start adding properties and methods to your element. All right, so you've registered a tag, but now like it doesn't really do much. I want to add some data to this thing. I want it to like come to life a little. So to make that easier on you, we've added binding expressions. And if you're familiar with the double mustache syntax from other libraries, things like Handlebars or Angular, this should feel kind of familiar. What we've got here is an owner element. And inside of the template, we're going to bind to this owner property. And that owner property is matched up on my prototype down here. So you can sort of see what's going on here. So that binding expression is just watching my prototype, and anytime that value changes in the prototype, it's going to change in my binding expression. So when someone uses owner element on their page, what they're going to get is Rob built me with Polymer, right? That's cool, but that's not like very dynamic. Like I want the user to be able to configure this thing. So to aid in that, we've also added publishable properties. Same element as before. We're using the same owner element, but now up here in the top right, we've got this attributes attribute. And what this allows us to do is expose an attribute to the user that the user can configure that's going to be two-way data bound to our prototype. So I'm going to focus this a little bit so you can see what's up. So this attribute right here is exposed to the user. It's looking at our prototype, which right now is just defaulting to Rob. And then whatever value gets set is going to end up in our binding expression. So down here at the bottom, when someone uses our owner element and they pass in Alex as the owner, that's going to update that binding, and now our element says, Alex built me with Polymer. Really easy. Okay, so I've got some data going into this thing now, but I want it to be interactive. I want people to click on it and for it to do stuff. So to do that, we've added declarative event handlers. So I'm going to show you really quick. Here we go. Let me focus in on this. So we've got another element that we're building here. It's got a button, this button down here that says click me. And we've got an on-dash-click event handler. Now this is different from on-click without the dash, and I'm going to come back to that and explain why in a second. But for now, just sort of hang in there. So it's an on-dash-click event handler that's looking at a set message action, which is defined down here on our prototype. And whenever set message runs, it's just going to change the value for this dot message in the instance to I was clicked. So we click on the button, and it updates the value to I was clicked using this event handler. Okay, so how is this different from on-click? And isn't on-click bad? I thought on-click was like a thing I'm not supposed to use. So in a traditional website, you probably don't want to use on-click, right? Because you're going to end up with on-clicks all mixed into your markup and reaching into your JavaScript. It's also going to eval the code that runs through it. It can kind of work in the global scope. There's a lot of reasons why you probably don't want to use on-click in your application. When you're working in a Polymer element, on-dash-click is a little bit different. So for starters, using it on a tag like this is kind of nice because we're not talking about a massive application here. This block of code that you see, that is my whole element. And on-dash-click cannot reach into the global scope to do anything. It can only work with my element's prototype in this little bitty enclosed space that it has. On-dash-click is also going to not only create my event handler, but it's going to make sure that it gets removed when the element is removed from the DOM. So it helps with memory leaks. And lastly, on-dash-click uses pointer events instead of regular mouse events. If you've never heard of pointer events, it's a new event model that unifies mouse events and touch events. So instead of having to add event listeners for both, you can just use on-dash-click and it'll normalize that and manage both for you. So again, just a way to save you from writing a whole bunch of boilerplate code. It's a bit of a developer nicety. The last thing I want to talk about is automatic node finding. So I'm working with an element, I'm making it interactive, now I need to target something inside of it so I can work with it. And this element's very similar to our last one. We're using on-dash-click again to call an action in the prototype. So we're calling this setFocus action. And inside of setFocus, we're looking for this $.name input. And you might look at that and think, jQuery? But we're not using jQuery here. What we've actually done is we've just taken any element inside of our template that has an ID, and we've mapped that to a hash, which we're storing in the $sign. So anytime you want to access something inside of a Polymer element that has an ID, you can just very easily say this $sign, whatever that ID is. In this case, we're looking at this input that has an ID of name input. So when I click this button, it's going to focus my text field down there. Okay, similar to the on-click discussion, I know a lot of you are probably thinking, I thought IDs were bad. And yes, in a traditional website, IDs are bad. You don't want to use IDs in a traditional website. When you're working with a Polymer element or custom elements in general, an ID inside of the template is scoped to the element itself. It's not global to the page. So it's okay to use IDs in an element. It's okay to stamp out multiple instances of that element and have those IDs in there, because again, they're just scoped to the elements themselves. And doing it this way just saves you from having to query selector for a class of items and then inspect the list that's returned to find the particular thing that you're looking for. It's just a way to write less code and to save you a little bit of time. Okay, so that was creating elements. And there's a bunch of other features that I didn't cover that are documented on our website. There's tons of cool stuff for doing like inheritance and other great stuff. But I want to move on to the platform layer down there at the bottom so you guys can understand how this thing is actually working. So as I mentioned before, the platform is just a layer of polyfills. It's adding support for all the web component standards in all modern browsers. And again, that's IE 10 and above and Safari 6 and above and mobile Safari. Basically what it's doing is it's taking the support picture for web components, which currently looks like this, and it's just making it look like this, right? And there's some additional features that the platform includes, which I haven't really talked about. Things like mutation observers, which lets you watch for changes on DOM nodes. Pointer events, which we did mention a little bit. Web animations, which is a unified animation model for doing CSS and programmatic JavaScript animations. So you can write your animations in JavaScript and have them run fast on the GPU. And there's a bunch of other things that I haven't talked about that are included in the platform, which are documented on the website. And the nice thing about it is, if you want to take any one of these, break it off of the platform and use it separately in one of your projects. If you only want web animations or you only want mutation observers, you can actually take just that polyfill out of the platform and use it separately. We want you to use all of these things. We want you to use them and to give us feedback to make sure that as they become native, they feel good to use. And the most important thing about the platform layer is that as the underlying specifications become native in the browsers, the need for the platform goes away. Right? If the platform sees that shadow DOM or imports are supported by the browser that it's just been loaded into, it's not going to polyfill anything. It's just going to opt in and let the native stuff take control. So what that means is that over time, the platform layer actually decreases. And eventually, it's just all gone, which is kind of cool because that means that Polymer actually gets smaller as it ages instead of getting bigger, which is really nice. All right, where to go to find out more information? Check out our website, polymerproject.org. There's a bunch of stuff there, tutorials, getting started guide, everything. We've got a little bit of time left, and so what I really want to do is I want to show you how to build something really quickly in Polymer, because I think it's way cooler to see this stuff in action than to just hear me talk about it. So, so that you don't have to watch me type a whole bunch of stuff, this is a tool that our team has created. Can you guys see that okay? Yeah? All right. This is a tool that our team has created called the Designer. It's available up on GitHub at polymer/designer. It's open source if you want to play around with it. We're not planning to ship an IDE anytime soon. This was just sort of like a hack project that one of the team members put together. But it illustrates some really important points, and it's really fun to work with. So what we're going to do here is we're going to build a little application just dragging elements out of the sidebar, configuring them, and binding them together. So I'm going to start with a toolbar. And if you guys look down here, if you sort of watch kind of down here in the bottom left, I don't know if you can see this super well, but there's this elements panel down here. And it's kind of hard to see in the back, but you can actually see the elements and how they're being nested inside of each other. I know you can't really see that well, but if you go check it out on GitHub, you can play around with it and see it. So you got this toolbar, and it's basically just a Polymer UI toolbar. It's just another tag like the ones that I was showing before. It's got some tags nested inside of it for Polymer UI icons. I don't need all of these, so I can kind of get rid of the ones that I don't need. I can configure this element, and over here in the sidebar, you can see these are just sort of normal HTML attributes, things like text content and ID and stuff like that. So I'm going to change the title to where am I. We're going to build a maps app. And then I need a Google Maps component. Yeah, all right. Okay, so I got Google Maps here, but I don't know, this is kind of boring to look at. It doesn't really do anything. So why don't we take one of those non-visual elements? We'll take the Polymer grid layout, add that. You can't see anything, but over here in the sidebar, I've got access to its attributes. So I can actually configure this guy. I can use grid layouts. Yeah, all right. Okay, so now I'm starting to get a little bit of a responsive application, which is kind of cool. But I think I could do a lot more. So let's add another UI element. Let's add a card to this. By the way, if this app starts to look familiar, let me know. So we're going to drop a card on here. And inside of that card, drop a couple fields. Okay. And we're going to configure these fields. So this guy, I'm going to give an ID of start. It's a placeholder, start, address. This guy, end address. I'm just setting IDs for these elements and then setting some placeholder text for them. So just configuring the HTML. My card is a little huge, so I'm going to set its height to auto, collapse it down. There we go. And let's see, the last thing I need to do, I need to make all this work together. I'm halfway there. So let's add Google Map directions. This is another non-visual element, so you're not going to see anything, but what I'm going to do is I'm going to work with its attributes and properties over here in the sidebar. So I'm going to bind its map property to the Google Map element that we've dropped on the page. I'm going to bind its start address to start element, to its value. Bind its end address to the end element's value. And now I can type in an address, and I can cross my fingers that this is going to work. Where are we? Sunnyvale? Sunnyvale, California. And boom, I get a route. Awesome. Okay, so in what, like 4 or 5 minutes, we've just built like an entire application, and we did it all just using elements. And I know it's a little hard to see, but if you can kind of zoom in down here, you can see that all it is like Polymer UI toolbar and Google Map and Polymer grid layout. We've just dropped a bunch of elements on the page and configured them all together using bindings. So I think that's all the time that I have. That's all the slides that I have, at least. Thank you guys so much for coming out. Slides are available up on robdodson.me/polymerbuildingblocks. Again, hit me up on Google+ or the Twitters or anything like that if you have questions when you're playing around with this stuff. Also, be sure to check out our forum, Polymer-dev, on Google Groups, and our Stack Overflow area under the Polymer tag. So thank you, guys.
Anybody that has questions for Alex and Rob, step up to the mic here, please.
Step up to the mic.
Rob, great presentation. Love it.
Presentation mode is now disabled.
Please repeat the questions for the video.
Sure. Okay.
So quick question between Polymer and Angular and how they kind of have overlapping technologies and purposes. How does that resolve going forward?
Okay. Do you want to repeat the question?
Yeah, so the question is, how do Polymer and Angular, how does that resolve going forward? They seem to be somewhat similar in some aspects. They're done by different teams, for sure. Angular is a really awesome framework that's designed for the web of today. The Polymer team is interesting because it's been part of the Blink team since the beginning. So when we started working on the web component standards, which I think was about 3.5 years ago now, we knew that it's really hard to design this stuff in a black box. If you get a bunch of smart people, you sit them down in the spec mailing list, the standards mailing list, or standards face-to-faces, it's really hard to know until you use this stuff if it's any good. So we knew from the very beginning that we wanted, as this stuff baked a bit more, we wanted to actually build a framework like Polymer so that we could try it out before it's really shipped in browsers and provide feedback right into that standards process. So that's what you're seeing with Polymer. So Polymer kind of started off as just a way to try out these concepts, and as we're playing with it, we were getting more and more excited. I think the company, Google, is getting more and more excited as we play with it, because when you let go of some of those constraints you have from the past, you get, the world just feels very different. So we have, Rob mentioned this, he showed off some of the UI elements we got today. Those basically are just random explorations. A number of them are just kind of are probably slight dead ends. Our plan is to make this into to provide a much more comprehensive set of UI elements that work together, have a cohesive style, and that allow you to write applications that work on a mobile and desktop more straightforwardly. So.
One thing that I would add is that the two are not mutually exclusive, if you were thinking that. So what we're showing here, again, they're just HTML elements. And since Angular knows how to work with HTML elements, there's a little library out there, I think it's called Angular Polymer Binding, to make the bindings actually work between the two. But the notion here is that we're just adding new tags to the browser. Angular knows how to work with tags in the browser, and so the two can live together.
And that's not special to Angular at all. It works. That's a nice thing about Polymer in general is every framework ever knows how to work with the DOM. So we just basically introduced some new elements to the DOM effectively. And so it means that it's generally actually pretty straightforward to interop with whatever else you're using. So. And the other thing that's important to note, by the way, is there's this notion of, from the outside, elements built with Polymer look just like built-in elements. From the inside, that's where you get your data binding and all that kind of stuff, all the Polymer goodness. But that doesn't leak out to the outside. So it doesn't interact oddly with other frameworks or anything.
Yeah, I ask because, templating in Angular or templating in Ember, they've got comprehensive solutions for that. Mm-hmm. But also in Polymer, there's templating, and then the binding scenarios, if you're doing a different binding within a Polymer element, and how does that?
So the question is around how templating and binding works across
Like which
Angular and
one
Polymer.
do you use if you're using?
So the way to think of it is Polymer elements, and Rob, I think, did a great job of explaining some of the properties of elements. The way that you configure elements that are built into the browser is via attributes. It's via properties and methods. They emit events when things happen. And that's how you should be designing your elements as well. So the way you pass stuff in is via attributes or via properties and methods. And so actually, generally, you don't need to do anything that special to work with other templating languages. You can just sort of stamp those elements and have attributes that pass in the information.
Thanks.
I don't even know if that mic's turned on, so you don't necessarily have to stand up.
Performance.
Yeah.
How fast is it? Now you're using it in anything in production.
Okay, so performance in production. So again, Polymer started off kind of as this experiment. Quite frankly, polyfilling shadow DOM is kind of crazy. Eric Arvinson, who's a member of TC39, is the wizard behind that one. It works. Our goal is to not be any slower than the sort of status quo tools today. But as you ship these things, as these technologies are shipped in browsers, that it just gets much, much faster. So I don't have any concrete numbers to share with you today. We have a number of different apps that have used it, and a growing number organically have started using it. Chromestats.com, which we use on the Blink team, uses it. One of my favorite examples is the Google Data Arts team helps build the Google Zeitgeist site that they do once a year. And they sent us an email a week after that site launched. And he goes, hey guys, on the public mailing list, hey guys, just want to let you know that we built this cool thing using Polymer. Thank you. And they included a link, and I was like, wait a second, I recognize that. And it was the Zeitgeist, one of the tabs of the Zeitgeist app that used Polymer in production for millions of users. We've also, these technologies, by the way, are not theoretical. If you go and use Canary, that's one of the reasons Rob was using Canary, and flip on experimental web platform features, you basically get all of it, and a couple other flags. Our plan is to ship those relatively soon. We're working with standards bodies to work out some, and Mozilla and others to work through remaining issues. But anecdotally, it's much faster. So it's already plenty fast, and it's like amazingly fast when you turn on, when you have a native implementation.
So it's just two files that we need to include on the page, the platform.js and the platform import platform.html.
So the question is you only have to include those two files to use Polymer?
So it kind of depends. If you want to create your own element, then platform and Polymer would be all you would need just to create like sort of a vanilla element that doesn't rely on anything else. Typically, if you want to include other elements, you need to import those as well. So a pretty common pattern is to just have a file called elements.html, and inside of that file, you would put like all of your imports, and then you can just like link that in. And there's also build tools that we have that will take all of your elements once you're ready to like go into production, mush them all into one file so you can actually launch that into production. That tool is called a Vulcanizer, and there's command line, grunt task, and things like that to make it work.
Yeah, so that one JS file is definitely required. How big is that one, that JS file?
Just top of your head?
Platform.js?
Yeah.
I don't know off the top of my head.
Platform.js, it's small. It's not. It's on the. It compares very favorably to existing frameworks.
Yeah.
I wish I could have that number off the top of my head. Sorry about that.
The mic is working as your mic.
And so another thing to mention is
okay.
That
he's loud.
Platform.js. That's the way that you include that on your page. You can now pretend like web components exist natively in the browser. From that point on, all the includes and things you do are just for the elements that you're using. And those elements themselves may be built with Polymer, they might be built with X tags or Brick or any other number of frameworks. They're all basically the same in that respect.
This is the WebEx mic.
Oh, wow, okay. Sorry, WebEx that couldn't hear apparently anything.
How can they be restyled? Like somebody uses maybe the existing element and then has a different need, different shape, whatever.
Do you want to repeat?
Sure, yeah. So the question is, how do you style existing elements? Are you talking about an element like select that already exists in the browser, or are you talking about like another custom element that someone created?
Custom element.
Okay, like one that I created or somebody else created, yeah.
Yep. Because the style is in
right.
in there, right? And all the event handling is all in there, JavaScript.
Yeah, so there's a few ways to do it, but probably the most common way at the moment is there are some new CSS selectors that are being added, combinators actually. And that is still kind of very much in flux. We're working with the standards bodies to figure out, what the final version of this is going to be. But there are new combinators that actually will let you specifically pierce the shadow boundary and style something. And the reason why we're using new combinators for that is so that you don't accidentally pierce the shadow boundary. You know exactly what you're doing when you reach in there and you style something. And the hope is that a developer is going to have, classes on the elements that they want you to style, and then they'll write that down in their documentation. Or you can see all of these things inside of the Chrome Dev Tools. There's a flag called Show Shadow DOM, which will actually let you open it up and you can see everything. And so, if the developer exposes classes, you just target those using these new selectors. They're called the cat in the hat at the moment. It's like an up caret and a double up caret.
They're as of right now, they are not the cat in the hat. Actually, it very recently changed. So. So this is a question. What's at issue right now? Actually, the standards bodies are in agreement. The discussion is generally in agreement about the need for these. And now it's a spike shedding. It's just exactly what they're called at the moment. They're called /shadow/. And that's supposed to be so you'd write that in your selector, so it's very clear to you that you're doing something special, and you should be a little bit careful about what you're doing. I want to make one meta point as well about elements. So today. When you make a decision as a developer about what framework to use, you're making a decision about their entire ecosystem of elements and components and that kind of thing. And which means that there's a lot of pressure for them to have a pretty good set of these elements, but there isn't necessarily competition on the element by element for each one to make them 100% as good as they could be, to make them accessible and internationalizable and themable and blah, 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 blah. And so what's interesting about web components is it makes it much less important where it came from. You can use an element that the Polymer team wrote, that you wrote, that the Xtags team at Mozilla wrote, that any number of other frameworks have written, and they should just generally be drop-in replacements. I mean, yes, of course, you're going to change, the APIs are going to be slightly different, but it's not like you have to completely, this component was written in YUI, it doesn't work with the closure component very well. They should work together much more straightforwardly. And so I expect personally, one of the reasons I'm so excited about web components and Polymer is because I expect that you'll see a lot more competition on the individual element levels, so you'll see a lot more of a drive to make the best calendar component, the best whatever component. And one aspect of that will be easy themability, accessibility, and that kind of stuff. Browser support. So it works with these polyfills. It works in all modern browsers. We define that as the most important one that you're probably worrying about is IE, and for us, it's IE 10 plus. And the reason is we don't want to stretch it. We want to make it. This fundamentally is a temporary compatibility layer. And so if we had to really contort ourselves into knots, so that when we get to this glorious future where it's just you don't need this compatibility layer, if you're still twisted in knots, that wouldn't be great. And so we want to make sure that we balance allowing you to use it today with making sure that we don't have to do any really crazy contortions. So IE 10 plus, Firefox, all the recent versions, Safari 6 plus, including mobile Safari, Chrome wherever it runs, and other browsers like that. Opera, which I mean at this point is
Come on, sorry.
Okay, there are homies. We love Opera's great.
How difficult is it to define a new element which contain arbitrary child elements? Like I want to make something super div.
So the question is, how hard is it to make elements that can have arbitrary child elements? That's something that actually Rob didn't show off. It's very easy. So there's an element called content. This is actually built into the web component specs. And it basically will teleport any logical children that are beneath you in the DOM and just sort of make them look as though they are in that position. Logically, they'll still be children of the real element, but they'll, at render time, they pretend like they are placed in that place in the DOM. So it's very easy, is the answer.
By the way, the 014 platform.js is 170K uncompressed.
Yeah, so that's 178 uncompressed. When you compress it, we find it compresses very favorably compared to others as well. Ben?
Yeah, question, how do you debug a Polymer element?
How do you debug a Polymer element?
Well,
which one? So the same way that you would just sort of debug anything else on your page. So the Chrome Dev Tools do a really good job of inspecting inside of Polymer elements. So you can just look inside of there if you need to, and put breakpoints in for your script and things like that. So no real difference from anything else in the document.
So I think an interesting meta point is when you embrace this everything is an element mantra, you find yourself writing a lot less script. So instead of having a big bundle of script, you find yourselves breaking your application into elements, and each individual element has far less script. And some of them have no script at all. It's just data binding. In this more declarative world, like tools like Chrome DevTools are really good at you digging into JavaScript, right, into putting breakpoints and that kind of thing. And I think in this more declarative world, there are different types of tools that are necessary, I think. So you have all the same tools you've got today. I think there's a potential for lots more interesting tools that allow you to dig in more into how the data binding precisely is working. And again, because we are on the Blink team, we literally sit inside the Blink team. I'm product manager on both Polymer and Blink. We work constantly, very closely with those guys, and can help find performance problems in the native implementations, make sure that they do all the right things, and also suggest features and that kind of stuff.
All right, thanks you guys. Appreciate you coming.